All right, today we're covering ground reference maneuvers. Here's a plan. We'll start with an introduction. We'll get into the rectangular course, turns around a point, and then S turns, and then we'll do a Q&A at the end. If you have any questions throughout the entire presentation, just go ahead and ask. All right, so first of all, introduction. My name is Monty. I'm a CFI. I founded the Emerald Squadron Aviation. I'm working on creating a ground school, making it available to everybody. And my whole goal in life is to help you earn your wings. So if you want to become a pilot, all right, so that's introduction. Let's get into the rectangular course. Now, the rectangular course, the objective of this is you should develop knowledge of the elements related to the rectangular course and the elements involved in maintaining a proper ground track. The student will have the ability to perform the maneuver as required in the ACS or the PTS. And the ACS stands for the Airman Certification Standard. So the key elements I want you to take away from this, first of all, plan ahead. In aviation, you always want to have a good idea of what you're doing. Next is wind corrections, recognize when there is a crosswind and what to do. And then maintaining coordination. You really want to, always have good coordination. That means that the aircraft is not slipping or skidding and everybody's comfortable in the plane. Let's get to it. So here are the elements we're going to cover for the rectangular course. First of all, we're going to talk about selecting an altitude, selecting a reference point, the basics of the rectangular course, and how to perform the rectangular course. So this is what it looks like. It's literally a rectangle around a field, a rectangular field, and it's meant to emulate the traffic pattern here at an airport. You've got the downwind leg, you've got the base leg, the upwind leg, and the crosswind leg, and it's all referring, to the wind. So a big part of the rectangular course is learning how to account for wind and how to, adjust your aircraft so that it is, crabbing correctly. So let's talk about selecting your altitude and your reference point. First of all, your entry altitude. The ACS says that you have to be between 600 and 1,000 feet above the surface, and you have plus or minus 100 feet to play with. So if you are at 600 feet and you go below that, you are gonna bust because you're way too low. And if you start at 1,000 feet and you go to 1,001 feet, you again are gonna bust, according to the regulations. So you want to pick somewhere in between these two that will give you 100 feet of buffer to play with. So 800 feet above the ground is a good balance point between 600 and 1,000 feet above the ground. So 800 feet AGL. And so you really want to know what altitude what altitude above sea level the point you're flying over, or the field you're flying over. Now, selecting a good reference point. You want a rectangular field or some sort of rectangular kind of looking thing on the ground, maybe a set of roads, so you can have a good reference point. And again, the whole point is to emulate a traffic pattern. The last time I flew it, I actually used a railroad as my reference point, and that worked really well. You want to select a reference point that is going to give you a good, area to land in if you need to. Maybe not the exact field you're flying over, but like if there's like a runway or somewhere nearby, if you lose an engine, you should be able to glide down to a safe area. And that's in general. Anytime you're maneuvering, you always want to have your next available landing spot selected and in the back of your mind in case you lose an engine. By the way, real quick, what do you do if you lose an engine? ABC. A, airspeed. B, best place to land. And C, checklist. A is your airspeed, your best glide speed. And the 172, that's going to be about 65 knots. Trim for hands-off flight. So if you lose your engine, trim your airplane for 65 knots. Take your hands off the controls, and you should be able to just glide down on its own. B, best place to land. Look around, and you should have that selected already. And then C is your checklist. Break out your checklist and start working the problem. Now, this altitude, you're not really going to have a lot of time to play with the aircraft. Basically get it, trimmed for hands-off flight, select a good place to land, and then land, because you've only got about, 600, 800 feet to go. And then you also want to refer to the METAR or look around at smokestacks, water, trees, fields for any wind indication so that you can enter on the downwind. That is a big part of the maneuver, knowing what the wind is doing and learning how to account for it. So know where the wind is coming from. And just like the traffic pattern, we want to enter on the 45 to the downwind leg. So if the wind is blowing, from the bottom of our page to the top, we want to enter on this 45 here, and this will be the start of our rectangular course. So like I said before, the rectangular course is meant to emulate the traffic pattern. And it's just like the traffic pattern. It's flown parallel to the boundaries, about half mile to a quarter mile from the boundaries. And the whole point again is to practice your traffic pattern at a higher altitude than you normally would. We're going to be doing a lot of wind correction, crabbing into the wind, and adjusting your roll rate and bank angle depending on the wind, your ground speed, and other factors. So remember, the key thing here is to remain coordinated. So you see that little airplane in your or the instrument that looks kind of like this. That's a turn coordinator, and you want to make sure this ball stays centered. And then that basically means that you're being pulled straight down into your seat rather than slipping or skidding and having the centrifugal forces pushing you in and out of the aircraft or to the inside and outside of banks. And then you want to select your maneuver speed, and you want to stay within 10 knots, plus or minus 10 knots of that maneuver speed. So those are the basics. Now let's talk about actually performing the rectangular course. Like I said before, you want to know what your wind is doing, so check the METARs, look around for smokestacks, or just maintain good situational awareness and know where the wind's coming from. Now, before we start any maneuver, we're going to do clearing turns. Use your maneuver checklists, do clearing turns. That means you're doing a left turn and then a right turn to check the airspace, or doing a full 360 to clear for traffic. Then you want to establish your altitude before you get anywhere near the course. Establish your altitude, establish your airspeed, trim for level flight, take your hands off the controls. Everything should be stable and chill before you even start the maneuver. And then you want to figure out where you are, orient yourself, and then get on that 45 for the downwind leg. I'm telling you, if you have your aircraft trimmed for hands-off flight before you get anywhere near the rectangular course or any other maneuver, it's going to set yourself up for success. Okay, so like I said, enter on the 45, and then because you should theoretically be downwind here, there should be no wind correction needed here. Once you are turning to the base leg, imagine this is a huge wind, like hurricane level winds. If you want to stay on this, parallel to this leg here, you're going to have to crab into the wind. If you were to just make a regular 90-degree turn like this, you would be blown off with that super high hurricane force winds. So we need to correct for that, and that's called crabbing. So we're going to make a greater than 90-degree turn here on this first leg. We're going to crab on the base leg. And then we're going to turn again to the upwind. Because there's no crosswind in this case, this turn is going to be a lot shallower. It's going to be less than 90 degrees. And we're going to, fly upwind. And because there's no wind, there's no crosswind, we're not going to be crabbing. And then we're going to turn to the crosswind leg. And here, because the wind is blowing again across, giving us a crosswind, we're going to turn and crab into the wind. So this will be less than 90 degrees. And if it were to be a 90-degree turn like this, we would be blown off course. And this is what it would look like that. So that's why we have to establish a good crab angle. And again, the whole point of this is learning how to do this properly, how to crab properly. So the first couple of times you do it, you might get blown around. That's okay. Go up and keep practicing. And what I like to do sometimes is practice radio calls here. Like once you get good at the crab angles and maneuvering the aircraft, maintaining good situational awareness, I like to add in radio calls with my students. So here, hey, pick an airfield, Arlington traffic, Cessna 12345, on the 45 for the downwind for runway so and so, Arlington traffic. And then you do your turns and keep making your radio calls here and here and here for the base upwind and crosswind legs. And then once you're ready to depart, you can you can exit 45-degree angle downwind, just like you normally would. Bam. So that is the rectangular course. Again, the key elements here are maintaining coordination, establishing proper crosswind angles or crab angles for the crosswind, and maintaining good situational awareness. What are your questions at this time? And if you have any, while I doodle here. And if there are no questions, no worries. You guys seen my screen okay? Last time I didn't realize my screen wasn't sharing.
I see it.
That. Yeah, awesome. Glad to hear it. Cool. If there are no other questions, or if there are no questions for this portion, we'll move on and go talk about turns around a point. So we covered the introduction, we covered the rectangular course. Now we're talking about turns around a point. So similar to the, hey, how you doing? Sorry, my dog is here. Similar to the rectangular course, turns around a point are there to help us understand the relationship between the aircraft, ground speed, and wind. So we're going to learn how to divide our attention between what we're doing inside the aircraft, the ground references, the controls and everything. Adjusting our bank angle for ground speed changes, improving competency in managing quickly changing bank angles, establishing and correct wind correction angle to maintain track over the ground, compensating for drift, and develop better situational awareness and the awareness that the radius of the turn is correlated to the bank angle. So there's a lot that we're learning from these ground reference maneuvers. Like the rectangular course, the ACS says somewhere between 600 and 1,000 feet, plus or minus 100. But remember, if you are at 600 and you go below that, you've busted it. And so you want to select an altitude somewhere in between here. That's going to also give you that 100 foot buffer. So 800 feet above the ground is a good rule of thumb. Now, for your it turns around a point, right? Yeah, for the turns around a point, you want to select something prominent and easily distinguishable, but small enough to be precise, right? So you don't want to select a giant football stadium or whatever. You want to select maybe a T intersection or a barn or something small enough to where it's going to give you a challenge, but big enough to where you can identify it easily. And then you also want to keep in mind if you need to make an emergency landing, if you lose an engine, we're going to glide somewhere. So pick a reference point that is close enough to a field or a runway or something that you can glide down to. And let's recap. What happens if you lose an engine? ABCs: A, airspeed, best glide speed; B, best place to land; and C, checklist. Start working that problem. All right, so let's talk about turns around a point. The maneuver is consecutive constant radius 360-degree turns where bank, rate of turn, and wind correction angle are constantly adjusted due to the wind's effect at different points in the turn. So the whole point of this is that you are constantly changing stuff. Just like before, we're going to enter on the downwind. And then because we are constantly flying this circle, it's going to be changing bank angles, changing crab angles the entire time. Now, we want to stay at the same altitude. This is different from eights on pylons. We're supposed to be at the same altitude here. So you want to be careful. One common error is keeping your focus mostly on your instruments. We want to spend most of our time looking up and out of the aircraft for other traffic, terrain, and our reference point. And then 10% of our time is back down here verifying what we expect to see with our instruments. Now, the roll rate, that's how fast you enter the turn. This is going to change depending on how fast your ground speed is. So if you are at a high ground speed, the wind is pushing you away from your reference point. You're going to be rolling more aggressively, high rate of roll, rather than, if you're being pushed toward the reference point, you're going to have a lower ground speed and low rate of roll. Basically, the way I have to think about it is, what's the wind doing to me while I'm flying this, right? If I am flying in this direction and the wind is pushing in this direction, what does the wind going to do? It's going to help me make this turn. So I have to, or it's going to push me farther away from my point. So I need to make a more aggressive turn in this direction. Whereas if I'm coming from this direction, the wind is actually going to push me towards my turn. So I don't need to make as sharp or as aggressive maneuvering here, right? So it's going to help me come back to this point, while this one's going to push me even further away from it. Now, your bank angle is going to, again, similar to what I just said, it's going to depend on what the wind is doing. So the steeper or the higher ground speed, the steeper the angle of bank. So the higher ground speed, the higher bank. Wind correction angle, the stronger the crosswind, the greater the crab required. For example, if we're flying in this direction with no wind, our nose is going to be pointed in the direction we're going in. But if we suddenly have a crosswind from the left and we continue with our nose pointed in the same direction, we're actually going to get pushed off course like this. That's why we crab into the wind. That way, the wind is pushing us in the direction we want to go. and we'll actually crab, like a little crab, in the direction we want to fly. And the greater that crosswind is, the greater that crab angle is going to be, right? Coordination, key. You want to maintain coordination because if you enter a stall when you're uncoordinated, you could spin the aircraft. And at this altitude, could be very hazardous. And like I said before, 90% of your time should be spent outside looking for other pilot, other aircraft, other terrain, that kind of stuff. And then 10% verifying what you expect to see in your instruments. Now, prior to performing the maneuver, like we said before, your checklist, perform your clearing turns, left, right, or a full 360. Do your checklist, make sure you're at maneuver speed, trim for hands-off flight at your altitude before you get there. And that should be, when you go to your traffic pattern, when you start landing the aircraft, that should be a key thing, right? Have the aircraft trimmed for hands-off flight at traffic pattern altitude before you get to the downwind leg, or before you get to the 45 for the downwind, because you don't want to come screaming in, diving into the pattern, right? So we've done our checklist, we've done our clearing turns, we've trimmed the plane for hands-off flight at altitude and airspeed, and we have picked our reference point, and we want to enter on the downwind leg, right? Like that. Now, we want to be about a quarter mile to a half mile away from our point, and we are going to be making our steepest bank at this point because our ground speed is really, really high. Again, the wind is pushing us away from this point, so we have to account for that. Very steep angle of bank, and then we're going to slowly roll out of our bank until we are practically wings level upwind of the point. And then we'll continue to make steeper and steeper banks as we perform the second half of the turn here, and then coming back to our steepest bank. Now, I like to do 3 of these for practice, do 1, 2, 3. The ACS doesn't actually specify how many times you have to do it, if I recall correctly. Basically, the examiner wants to see you do it and perform it well. So practice until you get it right. And then actually practice until you can't get it wrong. There we go. Yeah, I think we already talked about most of this, actually. Yeah. And the second half. Yeah, I did it all on the previous slide. Apologies. Anyways, any questions about turns around a point?
Just a quick question. You mentioned the altitude to be approaching the turn. Is this just referring to what altitude you should do it when you're doing like flight training?
Yeah, so when we do our maneuvers, our ground reference maneuvers, the whole point of these is that you're supposed to be maneuvering while looking at the ground, right? The whole point is that you are able to fly the plane like while referencing ground stuff, like things on the ground. And so the ACS, or the Airman Certification Standards, gives you a range of altitudes that you can be at, the lowest of which is 600 feet, the highest is 1,000 feet. And it gives you a buffer of 100 feet from whatever altitude you select. But again, remembering that 600 is that absolute floor. So that's why we say 800 feet above the ground is probably best, so that you have some buffer room, both for the exam and for being safe.
Okay.
Yeah. Good question. Cool. Let's talk about S-turns now. Now, similar to the rectangular course, turns around a point, it's basically learning how to account for wind drift and maneuvering, close to the ground. Again, we're going to practice dividing our attention, adjusting the bank angle for the correct ground speed changes, and maintaining constant radius turns, and roll out from a turn with the required wind correction to compensate for wind drift. Like I said before, wind drift, this whole section of maneuvers, a lot of it has to do with learning how to account for wind. We want to establish and correct the wind correction angle and maintain track over the ground, compensate for drift, and arrive at specific points on required headings. Like we said before, that block altitude 600 to 1,000 feet, according to the Airman Certification Standard, plus or minus 100, so that 800 is a good rule of thumb. Now, for this, we want to select a reference line. Now, before, the rectangular course was, a field. The turns around a point were like a little barn or something. Now we want to select a road or a highway, something like that. And then we want to figure out what the wind is doing using METAR, smoke, water, visual cues to figure out where the wind is coming from. And then, and again, as always, have our emergency landing point in mind. And what are the ABCs of an engine failure? A, B, C. A is airspeed, your best glide speed, which is 65, and then 172. B is your best place to land, and then C is your checklist. And we're going to harp on that a lot. I want you guys to have that memorized. I want that to be second nature. Like, engine failure, go, right? Anyways, let's talk about the basics. Now, like the other two maneuvers, we want to enter on the downwind, perpendicular this time to the reference line. So before we were entering the downwind and we were flying, parallel to, like, say, the rectangular course. In this case, we're flying perpendicular. Now we want to cross perpendicular to the reference line and begin a 180-degree turn. Similar to the turns around a point, we're going to make our steepest angle of bank when we're on the downwind because the wind is pushing us away from our line. And then we want to make the more shallow turns when we're upwind. And then because the wind is pushing us back towards that reference. Now, basically, the entire time we're going to be adjusting our wings, angle of bank, and crab angles based on what the winds are doing. And we want to begin an identical constant radius turn in the opposite direction once we cross this line here. So it should be roll into the bank, should be pretty steep, roll out gently, and then finally almost wings level when we were crossing the road, and then basically roll right back into a shallow bank. Now, this is not going to be as aggressive a maneuver because our ground speed is going to be lower. A shallow bank, and then we're going to make it steeper and steeper and steeper until we are almost a beam, and then we want to be wings level again as we cross that reference line. Now, to maintain a constant radius bank, roll rate, and wind correction angle are adjusted for changing ground speed and winds. Like I said, the higher your ground speed is, the steeper your angle of bank is going to be. Here we've got a low ground speed, so our shallow angle is going to be the shallowest here. Now, the roll rate, like we said before, is how fast you roll into the turn. And again, the higher your ground speed, the higher your rate of roll. Bank angle, same. And then crabbing into the wind, like we said before. The more crosswind you'll have, the more you're going to have to crab into it to account for that drift. Right? Now, here, we want to stay ahead of the aircraft. In general, always have your next 2 or 3 moves planned out. Think about what you're going to be doing next, because if you start falling behind the aircraft, things are going to get out of whack pretty quick. So stay ahead of the aircraft, study, plan what you're going to be doing before you go do it, and then execute your plan. I feel like I've already done this. So like we said before, do your pre-maneuver checklist, do your clearing turns, make left, right, or a full 360 to check the airspace for other traffic. Trim for hands-off flight at your altitude and airspeed so that you can fly, hands-free, and then pick your reference line and plan to enter on the downwind leg. Now remember, 800 feet is our sweet spot, trimmed for hands-off flight. Now here's some other things you want to keep in mind. Trim. Trim is your friend. In general, trim is the best. It's the poor man's autopilot. If you can get good with the trim, you'll be set up for success. If you fly with me, I'm going to have you practice setting your trim for different situations in flight. We'll start with straight and level, and then we'll practice trimming for climbs, for descents, for approaches to landing, steep turns. Even when you're entering a turn, you can retrim the aircraft for hands-off flight. So trim is your friend. As the bank angle increases, back elevator pressure needs to be increased to maintain altitude. Basically, what that's saying is when you're flying straight and level like this, that tail is kind of big, your lift vector is purely vertical, right? But when you roll to the left, let's say, your lift vector suddenly has vertical and horizontal components. And that horizontal component of lift is what turns the aircraft. But because we've converted some of our vertical lift to horizontal lift, we actually lose vertical lift. And so the aircraft is going to want to descend a little. So we will have to adjust for that with back pressure or a little bit of power. And then divide your attention. We said it before, we're going to say it again. 90% of your time should be up and outside of the aircraft, scanning for traffic, scanning for terrain, and then 10% of your time is inside verifying with your instruments and navigational stuff. You want to maintain constant airspeed. Constant power setting and stable altitude go a long way in maintaining constant airspeed. Like I said before, trim the plane off. You should be relaxed and comfortable in straight and level flight before we start the maneuver, right? And coordination, as always, maintain proper coordination. A problem you see with students is they try to use rudder to adjust for what they think is the right turning or bank angle. It's the rudder is always used for coordination, not for your turns, if that makes sense. So maintain coordination. What are your questions?
I do not have questions.
Cool. Sounds good. All right. So the next steps, we kept this one short today. The next steps, if you haven't started flying yet, I would suggest signing up for a discovery flight. You can DM me or go to your local flight school and get started. And then keep studying. I'm actually thinking about publishing all of my ground school videos on YouTube rather than just the website. We'll see. We'll see how that goes. And if you have any questions for me, feel free to DM me throughout the week. And then if you want to see other topics covered, not just the ACS and the PTS, if there's anything else you want to know about, like mountain flying or, I don't know, any aviation topic, let me know and I'll research it and I'll do a discussion on it. Other than that, I appreciate you coming to hang out.
Thanks, Monty.
Yep. See ya.